Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to use the half reaction method of balancing redox reactions that are in an aqueous solution and the solution is acidic. So the first problem I'm going to do is this one right here. So the first step you want to do is when you're doing this method is to break it up into its two half reactions, meaning the redox reaction, the reduction reaction and the oxidation reaction. So you first have to identify what's being oxidized and what's being reduced. And so if you remember the mnemonic device, there's two of them. You can remember oil rig, or you can remember Leo Ger. And both of these are helpful in remembering the difference between oxidation and reduction. So oxidation, oil is oxidation is loss of electrons, and reduction is gain of electrons. And Leo Ger is the same thing. So loss of electrons is oxidation, gain of electrons is reduction. So either one of these should be fine in remembering the difference between oxidation and reduction. So with this in mind, we need to identify what's being oxidized and what's being reduced. So you look at aluminum first. Aluminum goes from 0 charged to 3 plus. So is it losing electrons or is it gaining electrons? Well, electrons are negative. So if it's gaining electrons, it would become more negative. But it became more positive. So it's losing electrons. So oil, oxidation is loss of electrons. So that means that aluminum is being oxidized. So that'll be one equation we will look like. So we'll write that down. So aluminum solid goes to aluminum 3 plus. So that's half of our reaction. And then the other one, it must be reduction, but let's verify that. So we're going from copper 2 plus to copper with a 0 charge. So it's becoming less positive, or another way, it's becoming more negative. So this must gain electrons, and gain of electrons, reduction is gain of electrons, so that's being reduced. So this is the oxidation half reaction, and then the reduction half reaction is with copper. Copper 2 plus, aqueous, this is aqueous, going to copper solid. Okay, so now that we have the two half reactions, we're going to balance these separately. So I'm going to bring the reduction side over here. So if I write it over here, let me have, so Cu 2 plus aqueous goes to Cu solid. So I'm going to erase this. So this is the reduction side. Okay. So the first thing we want to do, now that we have these separated into two halves, we want to make sure that we both half reactions are balanced in terms of mass. So we're following the conservation of mass, the law of conservation of mass, which means that we're balancing the elements. We want to make sure we have the same number of elements on both sides. So here we have one aluminum. Here we have one aluminum, so that's balanced. Here we have one copper. Here we have another copper. We don't care about the charge, we just care about the particle. So it doesn't matter that I have one 2 plus here and not a 2 plus there. All that matters is I have one atom of copper and one atom of copper on both sides. It's balanced as far as the numbers go. So now that they're balanced, that's the first thing. You balance the number of elements on both sides. Once that is balanced, the next thing you need to balance is the charge. And the way you balance the charge is by adding electrons to the appropriate side of your equation. So for example, I have 0 charge on this side, but I have a +3 on this side. So in order to balance this out, I need to add electrons, but electrons are negative. So if I add negative electrons on this side, then I'm just making this negative and this is positive. That's not going to work. So I need to add electrons to this side in order to get them balanced. So if I add 3 electrons, like so, then I have a -3 and a +3. That makes it 0, and I have 0 on this side. So now it's balanced in charge. I do the same thing over here. So here I have 0, here I have a 2+, so I'm going to have to add a 2 electrons on this side. So now this is 0 charge on this side, and this is 0 charge on this side. So now the charge is balanced. So again, those are the 2 things you want to do. 1, balance the number of atoms on both sides, and then 2, balance the charge. So once you've done that and everything's balanced, now what you need to do is make sure you're going to add these back together. But before you do that, you need to make sure that the number of electrons are the same for both of these, so that way they can cancel out when you add them back together. So here I have 3 and here I have 2. So the common number between these two is going to be 6. So I'm going to have to multiply this by 2. So this will be 2 aluminum solid goes to 2 aluminum 3+ aqueous, and then I'll have +6 electrons. And then I'll have to multiply this one by 3, and then I'll get 6, let me bring it down here, I'll get 6 electrons here, plus 3 copper 2+ aqueous, and that's going to go to 3 copper solid. Okay, so now that I have my 2 halves, now they're balanced in charge, they're balanced in number of elements, and now they both have the same number of electrons. So when I add them back together, the electrons here are reactants. Here it's on the product side, they'll cancel out. So when I put these together, these are going to cancel out, and so I get 2 aluminum solid plus 3 copper 2+ aqueous, and that's going to go to, and now the products. So 2 aluminum solid, get rid of that. And then that's going to be plus 3 copper solid. And so this would be my final balanced equation. Okay. Is that it? Okay, so I hope that makes sense. If you like this video, I hope you got a lot out of this. I hope this was helpful. Please like, share, subscribe, and hit the notification bell, as well as make a comment in the comment section. Thanks for joining me. I'll see you next time.